Hey everyone! In this video, we're going to be doing a kinematics problem, which is how high will a ball thrown at an angle go? This is a physics 12 kinematics problem. We can tell because it's two-dimensional. Let's go ahead and highlight the key information. We have a ball that's thrown from ground level. That's just because I'm kind, and that tells us that our initial displacement of the ball is going to be 0. It doesn't have to be, and we can do ones without it, but it'll just simplify learning how to do this to start. It's at 30 meters per second, and it's at an angle of 60 degrees. We've been asked, how high will the ball go? As we're starting two-dimensional kinematics, the important thing to remember is that vertical velocity and horizontal velocity actually behave separately, and height is based only on vertical velocity. If you throw a ball, it doesn't matter how hard you throw it sideways, it matters how hard you throw it up. So we're going to have to break this 30 meter per second velocity into its vertical component. And if you've been working on any type of vector problems in physics, you know that we can break a vector into its vertical component by taking the magnitude, so that's the velocity, multiplied by the sine of its angle, which gives us the y component of our velocity is 30 sine 60 degrees. We can chuck this into the calculator, and what we find out is that the vertical component of our velocity is 26 meters per second. Not that 30, not that 30. That is not what we are going to be using to solve this problem. It's the 26. And once you have that 26, this just becomes a regular old one-dimensional kinematics problem. We got this. We got this. We're going to fill in our equation to figure out the height of a ball. D is equal to 1/2 at squared plus vit plus di. And we can fill in the parts that we know already because we know what gravity is. Gravity is negative 9.8. We don't know the times here, t squared. We know our vi. Not that 30. Not that 30. We're going to be using the 26. This is a vertical velocity question. We need the vertical velocity. And because I was kind and said it was at ground level, the di just disappears because it's 0. We can clean this up a little bit, and it just becomes d is equal to negative 4.9 t squared plus 26t. We got a nice little equation. We want to solve the max height of the ball. It's how high did the ball go? That's the max height. We're dealing with a quadratic right now. You gotta know, you clever little cupcakes, we're looking for the vertex. To get the vertex, we're going to use the equation negative b over 2a. I have t equals instead of x equals because we have t's in our equation here. And it's the same thing. We're looking at negative b over 2a. So t is equal to negative 26 over 2 times negative 4.9. We divide that out, and we're going to get that t equals 2.65 seconds. That is only the first part of our vertex. That is not our final answer. The question asked how high the ball will go, not when will it be the highest. But as soon as we have that time, we can fill it back into our equation for t. We just fill it back into that regular d equals equation. So we get negative 4.9 multiplied by the 2.65 squared plus 26, also multiplied by the 2.65. And when we work this out in the calculator by filling in that time, the time of our vertex, we get a distance of 34.4 meters. That is the vertex of our ball, which means that is the maximum height of our ball. Two-dimensional kinematics, we can still solve how we get these heights. You can do it. I hope that this video was helpful for you. I'm going to be looking through a few more videos on solving some other components of throwing balls at an angle, but if you have any questions, please feel free to leave them in the comments below, and thanks for watching.